Hello, dear listeners. We hope you are very well. Our group is made up by Ana Francini Solis Miranda, Roger Rojas Steller, María Celeste Navarro Mora, Tito Guanizo Rossi. Now we start. Biodiversity and Habitat.
Two important elements present in ecosystem services are biodiversity and habitat. Biodiversity is the variation of life forms on the planet, and the habitat is a place that meets the conditions for an organism, animal, or plant species to live. In recent decades, there has been an increase in the population of the city, which has resulted in a damage of the habitats and various native species of the banks of the Torres River. In this research and analysis will be made with the aim of providing solutions to this problem through eco-urban practices.
General objective: to propose a regenerative design for improved biodiversity and habitat at the water's margin to Torres rivers, applying the concept of eco-urbanism for the most affected section in the border area between Goicoechea and La Merced. Specific objectives: to identify the challenges and impacts faced by biodiversity and habitat in the studio area, locate the protection zones, research zones, and biocorridors that have been affected by encountered problems, looking for areas that have a greater capacity for regeneration, to design an intervention strategy based on eco-urbanism, taking into account nature-based solutions, regenerating areas at risk for biodiversity and habitat loss.
The uncontrolled urban growth of the city of San Jose directly affects the water bodies because alters the components of the hydrological cycle such as surface runoff and water quality. It modifies the volumes of water that flood the soil surface during rainy episodes. It exerts pressure on natural resources, which increase their deterioration. As a result to a faulty water resource management, all the ecosystems linked to water bodies are directly affected. Therefore, the ecosystem service of biodiversity and habitat. We identified two of the main challenges facing biodiversity and habitat caused by uncontrolled urban growth. Pollution of water bodies come from different sources. Some of the types of contaminations identified in the Torres River are sewage and greywater, fertilizers and agrochemicals, solid waste, sediment dragging, dumping of industrial waste, chemicals, grease, oils, and hydrocarbons. We identified critical areas in the middle and lower parts, where various bodies of water converge. On the other hand, there is an increase in the erosive capacity of the soil due to the modification of land used for urban development purposes. Since the surface is compacted and waterproofed, it directly affects the environment quality of both the river and the surrounding. Some of the negative effects we have identified in the Torres River are as follows: decreased water and nutrient absorption capacity, turbidity, increased runoff, sediment entrainment and deposition in water bodies, and water contamination. This map shows the increase in the degree of water contamination as it approaches the more urbanized areas. We can also observe some pictures that show the most critical points in terms of the challenges of contamination and soil erosion.
For a better understanding of this site, the map was divided into three sectors emphasizing the segmentation of the life zones present. According to the classification system Holdridge in 1967, there are three life zones in this microbasin: very humid low montane forest in the upper part, very humid pre-montane forest in the middle part, and finally a pre-montane humid forest on the lower part. The infrastructure of this site is analyzed. In Sector 1, we can see a high density of constructions along the banks of the Torres River invading it. Circles highlight critical areas. In Sector 2, we see a decrease in constructions near the riverbank, but there are still many buildings that are invading the bank, highlighted in circles. In Sector 3, we only have one critical zone. The riverbank is respected in the construction area. As we move towards the rural area, the invasion phenomenon diminishes.
The retreats regulated by Article 33 of the Forestry Law are limited, as well as the river banks that present urban invasion. In the same way, areas with richer potential are determined for the Torres River Basin. A variation in the use of the land regarding San Rafael district can be noticeable, with a retreat of the 15 meter for the basin. Similarly, the invasion of the riverbank and the most important recharge points are limited. It is the rural area that presents less river invasion, but there is agricultural management that negatively affects the health of biodiversity, soil, and water resources due to the use of agrochemicals.
The generality of biocorridors immediate to the Torres River is highlighted as a mechanism to show the green infrastructure at a macro level, thus allowing to define the areas that have the greatest potential for ecosystem regeneration. Similarly, it is proposed to view the road infrastructure as an area of urban potential to establish natural biocorridors on the immediate road network. In the turquoise spots, the biocorridors that depend on urban rivers to develop are indicated. The blue lines are the rivers, and the orange circles locate the area where we want to intervene. For the issue of soil erosion, the establishment of multi-layer plant covers is proposed, which cushions the impact of rain on the ground, increases water filtration, improves the stability and porosity of soils, retains a greater amount of sediment, among other benefits that contribute to the recovery of habitat and biodiversity. The use of native plants is the best guarantee of healthy functioning of the ecosystem since they are adapted to the characteristics of the site, which are an ideal alternative from an ecological, ethical, aesthetical, and practical point of view. Through these strategies and guidelines proposed above, it is intended to develop the third and final objective: to design a strategy based on eco-urban, based on nature-based solutions to restore risk areas using the green and blue infrastructure present in the study area.